So, as you guys can probably tell, I get pretty excited talking about these concepts. I don't want to jump too far ahead, but to pull it back a bit and get to the practical stuff, like how does this actually work? How do you take a raw data set or data stream, and manufacture a data asset out of it?
Well, that's a really great question and a very deep one. The how of manufacturing data assets, it's pretty much at the heart of data economics. And I think that we could spend pretty much the whole day exploring the answers. But we'll try to keep it brief here and focus on just a few key concepts. The most fundamental concept that we need to clarify is that of a data economic frame of reference. I've used this term a couple of times, and that's the same thing as a data economy, so that's interchangeable. What is a data economic frame of reference? Well, much like we need a frame of reference with an origin point for, let's say, any coordinate system to make sense, we need a data economic frame of reference for data assets and their related properties, features, and other concepts to exist. If I just gave you two numbers, you wouldn't be able to tell if it's a latitude and longitude or if it refers to, like, let's say, a specific mathematical graph. Similarly, for data assets to exist, there needs to be a data economic frame of reference. So as far as these products, these data assets built using digital data as raw material are concerned, their existence, their utility, their value are limited to the participants, which in this case are people, groups, organizations, even computers or physical machines, anything, any entity capable of doing work or expending energy within a specific data economic frame. So outside of these participants, the data asset has no meaning, no utility, no value. So we'll take it for granted that whenever we talk about a data asset or data asset market, etc., that they exist within a defined data economic frame of reference. Outside this data economic frame, a data asset is just an ordered set of ones and zeros. The second key concept is that in order to be used as a product, a standalone product that has utility, there are a set of features that that product needs to have. And this is not specific to digital data products, by the way. Like any product that you can use usually has these features. There's identity, which basically in this case means how the package of data representing the product or asset can be identified within the data economy and distinguished from its copies. Context, which is what the package of data within the product means to others. Utility, which is exactly how the data asset can be utilized, when, by whom, under what conditions. Value, which is basically the same as utility. It's a measure of utility, which is to express the value of a data asset as money or even as other data assets. So the manufacturer of a data asset needs to define and control at least these features, as well as have a means to express them to all the other participants in the data economic frame. Now, the concept of a data economic frame where we are able to pay with digital database products might sound alien, but we actually operate within data economies a fair bit already in our day-to-day lives. And we pay for things that are pretty much data assets. So a few examples. Simplest one would be to think of a loyalty card, let's say at a coffee shop. So the context there, the meaning of the loyalty card asset is that it tells you that a certain amount of coffees have been purchased. The use of that, the utility, is that it might get you a new cup of coffee. The process might be when it's transferred to a coffee shop employee. In this case, this is a data economic frame of reference with you, the customer, and the coffee shop. Similarly, let's say for credit card miles, what it says is that you've used your credit card to perform sufficient number of transactions to earn a certain amount of miles, which can then be used to access flights worth up to a certain amount of money. How? When transferred to the credit card company or an airline that is associated with the credit card company. Now note, the loyalty card has only meaning within the data economic frame of reference that contains you and the coffee shop. You can't go and use a loyalty card, let's say at Starbucks. Similarly, you can't necessarily use your miles at Walmart to buy whatever it is you might buy at Walmart. You have to go to a specific set of entities which are within the frame of reference to use it. And in fact, if you think about money, money is also a data asset. It means, like, let's say the US dollar means that it's one unit of credit from the US Treasury that can be utilized to access goods and services worth $1 when its ownership is transferred to another entity. And who's in that data economic frame of reference? Well, the US Treasury and all the entities that are using US dollar. And a very recent one is, let's say, Bitcoin, which again has very similar properties where a certain amount of energy has to be spent to create a Bitcoin. It can be used as a form of currency, but only within the data economic frame of reference of the Bitcoin network, the people who are mining the Bitcoin and Bitcoin users.
Yeah, I mean, all of this makes sense to me, but the thing, and we've talked about this a bit before. I mean, all of these data economies that exist out there, even if we are participating, generating the data through our actions, like generating a credit card mile when we buy something. I mean, that data at the end of the day is not really under our control. It's not owned by us or controlled by us. It's really controlled by either like the coffee shop in this case, or the company, or even in the Bitcoin network. It's controlled by that network. We don't have a lot of autonomy over how that's used.
That is exactly right, and that is the insight that I was driving towards. So while we are paying for things using digital data all the time, none of the data being used to create or manufacture these digital assets actually belongs to us, even if we generate it. That's where the Lydion data economic methodology and the Lydion data economic operating system, or DEOS, comes in. The primary goal of the Lydion DEOS is to allow the design and implementation of data assets and the data economic frames that they live within using any combination of data sets and data streams owned by the participants in that data economy. That is, Lydion data assets are created using data sets that we, companies and people, generate and own.
And what would you say, like, what's the key insight that drives this process and how it works?
The method that Lydion takes to turn data into data assets is actually very simple. Let's examine the context of the meaning of all of the real world data assets that we discussed so far. And we see that there's a pattern. The data asset itself is always the outcome or the result of work performed in the real world that requires a provable, non-trivial amount of energy being spent. Put another way, each data asset contains data expressing the proof of work performed or energy expended in the real world. And this data, with this proof of work, with this proof of energy expended, is bundled into the data asset as its context or for its very reason for existing.
So like I buy these 10 coffees at the coffee shop, and then I've proven that I have
exactly
coffees with my card.
Exactly. And your loyalty card data asset is, in that case, has that data in it. Lydion, the Lydion DEOS, just takes this concept and generalizes it into a framework in which any digital data set and data stream gets packaged up into these logical blocks that A, represent the proof, the measurement of results or outcomes, and B, these outcomes are created by some kind of work performed, a set of completed tasks, as we call it, that require some expenditure of energy. Each such package, each such logical block is a data asset. And that leads us to the key insight that is at the heart of the Lydion data economic methodology. The very existence of a Lydion data asset is the result of work performed, or more specifically, tasks completed in the real world. This work generated valuable results or outcomes that can be captured and expressed through digital data that is bundled into the data asset as context. If such work had not been completed, the data asset would not exist. So let's take a simple example to extend our earlier data assets to look at a Lydion data asset that, let's say, packages up your anonymized location data, as we had seen earlier. What is the context? What is the meaning? What is the reason for existing, for that data asset existing? It exists because the manufacturer of that data asset traveled through location X, some GPS coordinates, at time T. What are the new outcomes? What are the uses? What's the utility of this? Well, it can potentially be utilized by the manufacturer to gain access to money from the cell phone network or others, or, as we said, to gain access to other interesting services like Y hours of cell phone service. And how is it utilized? What's the process? When it's transferred, when you are giving permission to the telecom company, to the cell phone network, to use your location data for some reason, that whether they want to resell it, whether they license it or use it themselves. So a Lydion data asset created by the Lydion data economic operating system is a package comprising two types of data. The first is context, which is the data representing the meaning for its existence, which essentially is a set of these completed tasks that had to be completed and that had to generate results in order to generate this asset. This is further divided into what we call generation context and utility context. Won't go into the details, but generation context is basically the completed tasks that were required to generate the asset in the first place. The utility context are the tasks that were performed using or utilizing the asset after it was generated. The second type of data are the rules that are embedded in the data asset. And these are expressed as modular digital programs. We call these each machine, and they together form a data asset factory. And these rules control how that data asset is generated, utilized, and evaluated. The context and the rules within the data asset allow it to answer some very, very important questions for any participant within that data economic frame of reference. Who are you, and how can you be identified? Why were you made? What have you been utilized for in the past? What can you be used for in the future? And how can you prove these answers? The answers to these questions give the participant in the data economy all the information that they need to make decisions around the value and the utility of a specific type or a specific instance of that type of data asset.
Oh, sorry, I was muted this time. So the Lydion data economic operating system that you are working on developing with all of these research partners, I mean, this effectively creates data markets as well, right, for these data assets to be traded or exchanged within. Can you talk a bit about that next step up from the data asset where we're talking about a data market?
Yeah, sure. Why don't we talk about what it is that actually gets built out of the Lydion data economic operating system? So as you said, first and foremost, we have to consider this idea of a data asset market. The people and the organizations who are within a data economic frame of reference and generate or utilize a specific class of data asset are essentially are participants in a market. And that market exists only within that data economic frame of reference. And we call this a data asset market, or a DAM. Each data asset market, therefore, has three very important components: participants, the people who are generating and utilizing its assets; what we call a data asset factory, which is a set of digital programs called machines that enforce the identity, context, utility, and evaluation rules for that data asset type; and a data asset vault, which is a storage system, usually a database, that contains all of the instances of all of the data assets that are created and managed by that data asset market. So a Lydion data economic frame of reference, specifically of all of the data economic frames of reference we've seen, a Lydion data economic frame of reference, or a Lydion data economy, is just a set of data asset markets, each managing a single type or class of data asset that have the same set of participants. And this data economic frame of reference, these markets get implemented as what we call a data economic application, or a DE app. Now, each participant in a data economy has to have a way to participate in the data economy. And the idea here is that of a data economic node, which is really no different from a node in any digital network. A data economic node is just a computer that's running a data economic application, and that represents a specific participant's membership in that data economy's markets. So the data economic nodes running the same data economic application, implementing the same set of data economic markets, can communicate with each other, forming what we call a data economic network, or a DNet. That's an important concept. A DNet can be thought of as the real world representation of a Lydion data economic frame. So all of the markets and the assets that they create within a Lydion data economic frame are implemented in the real world by this data economic network, powered by one or more data economic applications. These applications together make up the final concept of a data economic solution, which are essentially products, software products, built using the Lydion data economic operating system that aim to address specific opportunities and problems in an industry through the implementation of data economic networks, or DENETs, in the real world. I believe that we'll see several examples of such data economic solutions that we've been developing using the Lydion DEOS with collaboration with our academic and industry partners, and learn a little bit about the impact that these solutions are having and can have, hopefully will have very soon in their respective fields. So Jen, honestly, we've just scratched the surface of data economics and the Lydion DEOS in this chat. I've gone through so many key concepts in a span of a few minutes. there is so much more to explore and discover. And, as you said, we'll have several opportunities coming up for our audience who want to go deeper into the science and technology coming up very soon. But in the meanwhile, whether someone here is interested in the economics, the math, the computer science, the real world impact, the business models of data economics, we would love to chat with you. So please